hello guys, welcome again to my YouTube channel. Today we want again to look at Hopital'S rule, the third method of evaluating limits. Now this is the simplest and the easiest and the most general method that can be used to calculate any given limit, so long as the limit is not a sad, or in short, it is not a rooted function. Any limit of a function that has roots, we don't use Hopital'S. For any other limit, whether trigonometric or any other kind, Hopital rule is applicable, and it is very easy and very direct. Now, my title is Hopital rules, and I've said used to solve all calculations involving limits except limits that contain surds or rooted function. Now, as easy as such, we're just going to go direct to an example. Now, we have already introduced what is limit and how we write limits. So if you haven't seen that, you can refer back to the third recording so that you can also understand what we did there. Factorization method and direct substitution method. Now here we are having an example limit as x tend to 1 of x power 7 plus 6x power 4 plus 9x cubed divided by x power 4 minus x squared. Now before we solve any question on limits using Hopital'S, I want simply to illustrate something related to differentiation. So how to differentiate an example. We have x power 3. This is how you do the differentiation. Bring the power of that function down. The power is 3. Write that function. The function is x. Lower its power by 1. It becomes raised to power 3 minus 1. So that now this one can now be simplified into 3x raised to power 2. That's how you differentiate. Bring the power of the function down, write that function, lower the power of that function by 1. Check this, x power 5. Bring the power of that function down, it becomes 5. Write the function is x. Lower its power by 1, so its power becomes 5 minus 1. Then move to the next part, minus. Bring the power of this function down, it is 3. When you bring it down, it will multiply 2, so it becomes 2 times 3. Write that function, the function that we have there is x. Lower its power by 1, it is power 3. So we lower the power by 1 minus 1. Then the next one there is plus. We have 6. 6 have an x, but our x is power 0. So bring the power of x down. It is 6 multiplied by 0. Write the function is x. Then it is raised to power 0 minus 1. Now this one simplifies into 5x raised to power 4, 5 minus 1 is 4, so x raised to power 4 minus 2 times 3 is 6. X is power 3 minus 1, so that is power 2. 6 times 0 is 0. Anything multiplied by 0 becomes 0. So in short, when you differentiate any constant, you get 0. Let me write that down. Differentiate any constant gives you 0. Now you have understood that. Now let's now move on to use direct substitution. The Hopital'S. Now, we say that for any given equation with limits, the first method must be direct substitution. So by direct substitution, you directly substitute there. Our function here is limit as x tend to 1 of x power 7, or so directly substitute where you have x with 1. So it means that we are going to be having 1 raised power 7. Oh, let me write this down here. So we are saying we are going to be having 1 raised power 7 plus 6 multiplied by, so into bracket, 1 raised power 4, then plus 9 into bracket 1 raised power 3, then denominator 1 raised power 4, denominator 1 raised power 4, and then we will be subtracting 1 raised power 2. Now when you do this calculation, you will be getting 1 plus 6 plus 9, and that one is 16. Then in the denominator we will be getting 1 minus 1, any 1 raised by any number is 1, and that is 0, and this is infinity. This is the same as infinity, and limit cannot be infinity. There are also, of course, cases we'll be able to see that later, where limit can be infinity. But for a limit that is tending to a value, the answer cannot be infinity. So we are going to use another method. So direct substitution fails. So let me write here, direct substitution fails. So we use another method. The next method that we can use is using Hopital'S. LH, that's the short. So using Hopital'S rule, then it means we are going to be having limit as x tend to that equals that. Now for Hopital'S rule, you differentiate both numerator and denominator, then try again direct substitution. If direct substitution fails again, differentiate again numerator and denominator, try again substitution, direct substitution. If it fails, continue until you get the right answer. Simple as such. So now let's differentiate. Now when I differentiate numerator, the first one here is x power 7. So I said bring the power down, it becomes 7. X raised power, lower the power by 1, it is 7 minus 1, which is power 6. Then plus 6, bring the power down, it is 4, so it is 6 times 4. Then write the function is x, lower the power is 4, lower by 1 becomes 3. Then plus, bring the power down, so it is 9 multiplied by the power is 3. Then write the function, lower the power by 1, 3 minus 1 is 2. Then come to the denominator. Again, bring the power down, the power is 4, so it becomes 4 x raised power, lower the power by 1 is 3. Minus, bring the power down, it becomes 2. Then x raised power 2 minus 1, which is 1. So can be left that way. Then I said, try again substitution. When you try again substitution now, so by direct substitution, what are we going to be getting? We are going to be getting we are substituting with 1. So let me make it into a simplified form. So when you simplify this one that we have here, so that I can write it down here, when you simplify this one that we have here, your numerator will be 7x raised to power 6 plus 6 by 4 is 24, 24x raised to power 24x raised to power 3 raised to power 3, and then we are having plus 9 by 3 is 27, so 27x raised to power 2, and then denominator will be having 4x raised to power 4 raised to power 3, I mean, and then in the denominator still will be having 2x. So now I'm saying by direct substitution, you directly substitute. When you directly substitute, it means that you in the numerator will be having 7 into 1 raised to power 6 plus 24 into 1 raised to power 3 plus 27 into 1 raised to power 2, and in the denominator we will be having 4 into 1 raised to power 3 minus 2 into 1. Now things are now becoming easier and easier and easier as you move along. So now 7 plus 24 plus 27, 7 plus 24 plus 27 is giving you 58. Then denominator we are having 4 minus 2 is giving you 2. So when you do your calculation, 58 divided by 2 will be equal to 29, and that is your answer. As simple as such. So guys, feel free to ask any question on LH. Just differentiate numerator and denominator, retry again direct substitution. If it fails, continue again until you get a real answer. You cannot get infinity. The answer is supposed to be real. So thank you for your time. Please subscribe and have a nice time.